everyone, welcome to my channel. I'm Solayao, a civil engineering student at Northwest Samar State University. And in this video, I will be walking you through some of the most important topics in integral calculus. First is logarithmic integration, second is trigonometric transformation, third is inverse trigonometric integration, and last is integration by parts. We will go over the concepts, formulas, and solve 5 sample problems for each topic, starting from easy to more challenging problems. So let's begin now. Now we'll be tackling first about logarithmic integration. Logarithmic integration typically involves integrals that lead to the natural logarithmic function. The general form is du over u is equal to ln, the absolute value of u, plus c. We use this when we see a function inside the denominator and its derivative is present in the numerator. For example, number 1, the integral of 1 over x dx. As you can see, this is equal to the natural log or to the general form of natural log. So the answer is going to be ln x plus c. So now we're going to put an absolute value around the x because we cannot have a negative number inside the natural log function. So now we're in the problem number 2. In this problem, we're going to use u substitution because as you can see, our numerator is the derivative of our denominator. So we're going to let u equal to our denominator, which is x squared plus 1. Then du is 2x dx. So now we're going to substitute this here. So as you can see, the value of du is equal to our numerator 2x dx. So we're going to substitute 2x dx into du. Since we already let our denominator equal to u, we're going to put it u here. And so as you can see, we can now apply the natural log function, the ln absolute value of u plus c. But this is not our final answer yet. We're going to substitute the value of u into our original given, which is the x squared plus 1. So it's going to be, so this is now our final answer. So we're going to proceed to our problem number 3. The integral of x over the square root of x squared plus 1 dx. So in this problem, we're also going to use the u substitution. So we're going to let u equal to x squared plus 1. Di natin kasama yung square root, yung nasa loob lang. And then, the du is 2x dx. So, as you can see, our numerator is only x dx. So, merong x's na 2 dito. So, gagawin natin is, we will divide it both sides by 2, cancel, and the value of x dx is equals to du over 2. So, now, parehas na sila. So, gagawin natin is, we're going to substitute also like what we did in a problem number 2. We're going to substitute x dx into du over 2. And since the denominator we already let to u, we're going to substitute it to u. Or simply, just raised to the power of 1/2. But we can also put the constant in front of the integral. We're going to put like this. Du over u 1/2. So next is, gagamitin natin yung power rule. The formula of power rule is u and du is equals to u raised to the power of n plus 1 over n plus 1 plus c. So para ma-apply natin siya dito sa ating problem, i-rewrite muna natin yung ating problem. So 1/2 integral of, itataas natin yung u. So magiging u raised to the power of negative 1 over 2 du. So as you can see, pwede natin apply yung power formula. So 1 over 2 u raised to the power of negative 1 half plus 1 over negative 1 over 2 plus 1 plus c. So magiging 1 over 2 u. Negative 1 half plus 1 is 1 half. Negative 1 half plus 1 is 1 half plus c. At next is, i-divide natin yung constant sa harap at yung denominator. So, pwede na i-cancel na lang. So, magiging u 1 half plus c. And then, substitute na yung value ng u sa ating original given, which is x squared plus 1. So, our final answer is the square root of x squared plus 1 plus c. Thanks. So now we are in the problem number 4. So as you can see, the exponent in the numerator is bigger than the exponent in the denominator. So gagamit tayo ngayon ng polynomial division. So, ilalagay natin sa loob yung numerator, which is x cubed. Sa labas naman yung denominator, x squared plus 1. So, x squared divided by x, no, x cubed divided by x squared is x. X times x squared is x cubed. X times 1, simply x. Now we need to subtract it. So x cubed cancel na and bring down the negative x. So now we can rewrite our new problem, which is x minus x over x squared plus 1. So this is now our new problem. It's more easy to integrate. So hiwalayin muna natin x dx minus x over x squared plus 1 dx. So dito, gagamit tayo ng power formula. So, x 1 plus 1 over 1 plus 1. Dito naman, gagamit tayo ng u substitution. So, we're going to let u equal to x squared plus 1. Then, du is 2x dx. So, kung mapapansin natin, merong x's na 2. So, we have to divide it both sides by 2. Cancel. So, the value of x dx is now du over 2. So, i-substitute lang natin ito dito sa ating original problem. So, and our numerator, we're going to substitute du over 2. Then, since we already let our denominator equal to u, so we're going to put u here. Or we can simply put the constant out in front of our integral. So, now is, we can solve it na. X squared over 2 minus 1 half. So as you can see, we can now use here the natural log function. So it's going to be ln u, the absolute value of u plus c. Then we need to substitute the real value of u in our original given, which is x squared plus 1. So x squared over 2 minus 1 half ln the absolute value of x squared plus 1 plus c. So this is now our final answer. So now we are in our last problem, which is the problem number 5. So first, we have to factor out first the x in our denominator. So 3x plus 5 over x squared plus 2x plus 1 dx. So since it's a perfect quadratic, we can rewrite this into x plus 1 squared. So now we can use the partial fraction. A over the first term is x plus b, x plus 1 plus c over x plus 1 squared. So now we have to find the value of each of these, but before that we have to multiply it both sides by x times x plus 1 squared. Now, multiply it by a, cancel yung x. Ang natira na lang is yung x plus 1 squared. Then b, cancel yung x plus 1, x plus 1 dito, natira na lang is x times x plus 1 plus c, cancel yung x squared, cancel yung x squared, yung natira na lang is yung x. Then we have to expand this and distribute this x sa loob. X. So to expand this, we have to use the FOIL method. X squared plus 2x plus 1 plus distribute this x. So bx squared plus x plus cx. Then we have to, next is hanapin natin yung x squared term. Since walang x squared dito, we're going to put 0 and a is merong x squared, so put a, plus b is merong x squared, so put b. Since yung c is wala, so di natin siya lalagay. Next is the x terms. So merong x terms dito, so lagay itong 3, plus, next is merong x term yung a, 2a, plus, meron ring x term yung b, which is b, plus, yung x term is c. Last is the constant. We have 5 here, so put 5. Then merong constant lang is yung a. So we already find the value of a. So now we have to substitute it to our first equation. So 0 is equals to a plus b. 0, we need to substitute the value of a, which is 5, plus b, transpose it to the another side, so negative 5 is equals to b. So this is our value of b. Since we already found the value of a and b, we can now use our second equation to find the value of c. 3 is equals to 2a plus b plus c. 3, substitute the value of a, which is 5, substitute the value of b, which is negative 5 plus c. Solve this. 10 negative 5 plus c. 3 is equals to 5 plus c. Transpose 5. So 3 negative 5 is equals to c. So the answer is negative 2 is equals to c. Since we already find the value of this 3, pwede natin siya i-substitute dito isa-isa. So, a is equal to 5 over x dx plus b is negative 5 over x plus 1 dx plus the integral of c is negative 2 x plus 1 squared. So next is we have to put the constant in front of the integral. So 5 1 over x dx plus, since it's negative, it's going to be negative here, negative 5 1 plus x plus 1 dx. Since it's negative also, so it's going to be negative. So 1 over x plus 1 squared. So here we, so now as you can see, pwede natin i-apply dito yung natural log function. So 5 ln the absolute value of x minus 5 ln the absolute value of x plus 1 minus. So dito, gagamitin natin, integral natin siya. So negative 2, 1 over x plus 1 squared. So next is, itataas natin yung denominator para ma-apply natin yung power rule. So negative 2, the integral of x plus 1 raised to the power of negative 2. So next is, i-apply natin yung power rule na negative 2 x plus 1 is the power of negative 2 plus 1 over negative 2 plus 1. So, magiging negative 2 x plus 1 raised to the power of negative 1 over negative 1. So now, para maging positive yung exponent ng numerator, ibababa natin siya. So magiging negative 2, negative 1 over x plus 1. So next is, itatimes natin yung constant sa numerator. So magiging 2 over x plus 1. Yan. So, next is, isa-substitute natin siya dito na. So, magiging plus
2 over x plus 1 plus c. So here is our final answer.
So now we are in our second topic, which is the trigonometric transformation. Trigonometric transformations are used to simplify integrals involving powers of cosine and sine or other trigonometric expression. Some common identities used include these. These identities help convert powers into solvable forms. We also use Pythagorean identities and double angle formulas when necessary.
To problem number 1, which is the integral of sine squared x dx. So as you can see, it matches this integral, so we can now substitute this integral into 1 minus cosine 2x over 2. So next is dx. So next is we're going to put the constant in front of the integral. So 1 half the integral of 1 minus cosine 2x dx. So next is i-split natin siya. So 1 half times this the integral of 1 dx minus cosine the integral of cosine 2x dx. So next is integral natin siya isa-isa. So una natin is integral of 1 dx is x minus the integral of cosine 2x dx is so equal cosine 2x d is equals to sine 2x over 2. So substitute natin to dito. So maging sine 2x over 2 plus plus c. So now i-distribute natin yung 1 half sa loob. So magiging 1 half x minus 1 over 2 sine squared x plus c. So this is our final answer. So now let's proceed to our problem number 2, which is the integral of cosine 2 times 3x dx. So now as you can see, it matches this identity. So now we can substitute into this. So the integral of 1 plus cosine. So ang to dito, itatimes lang siya sa 3. So magiging 6x over 2 dx. So next is ilalabas natin yung constant in front of the integral. So 1 half the integral of 1 plus cosine 6x dx. So next is split natin siya. So magiging 1 half times the integral of 1 dx plus the integral of cosine 6x dx. So next na is integral natin siya isa-isa. So first is this one. Maging 1 dx is x na lang plus the integral of cosine 6 dx is copy first cosine 6x dx. So maging integral na is the integral of cos is sine times 6x over 6. So ito na yung integral niya. So substitute lang natin dito. Maging sine 6x over 6 plus c. So next is i-distribute natin yung 1 half sa loob. So magiging ganito. Equal 1 over 2x plus 1 over 12. 2 times 6 is 12. So next is sine 6x plus c. So here is our final answer. So now let's proceed to our problem number 3. So sine x squared. Pwede natin siya substitute dito. So magiging super makancel ito mamaya. So magiging 1 minus cosine squared x over cosine x. So, i-split natin siya ngayon. So, magiging integral of 1 over cosine minus cosine squared x over cosine x. So, next is substitute natin to. Ito naman is ika-cancel natin. So, magiging second squared minus canceling sa ibaba, canceling sa taas. So, may bibilin pa na isa sa taas sa cosine x. So, now is integral natin siya. So, the integral of second is ln second x tan x minus the integral of cosine x is sine x plus c. So, here's our final answer. So, now let's proceed to our problem number 4. But first, muna ko dito ang extra identities kasi gagamitin natin siya mamaya dito sa ating problem. So, ito ay substitute natin dito sa ating given. So, kung makikita nyo yung ating numerator, pwede natin substitute dito. So, magiging 2 sine x cos x over yung denominator naman dito. So, magiging 2 cosine squared x. So, next is, ika-cancel natin yung 2, 2, cos. So, yung matitira na lamang is yung nasa itaas na sine x over cosine x sa baba. So, pwede natin ito i-substitute into the integral of tan x. So, now pwede natin siya integrate na. So, the integral of tan is negative ln cosine x plus c. So, here's our final answer. Now, let's proceed to our last problem, which is this. So, as you can see, the exponent is even and odd, so we can split the add 1. So, copy the cosine squared x. So, now split natin itong sine. So, sine squared x sine x dx. So, next is, para makancel itong sine x, substitute natin yung sine x squared dito sa identity. So, magiging copy lang yung cosine squared x. So, magiging 1 minus cosine squared x, copy yung sine x dx. So, para makancel na yung sin x, ilalat natin yung cos. We're going to let u is equal to cosine x. Then, du is negative sine x. So, substitute natin ito dito given. So, since we already let cos equal to u, so ilalat yun natin yung cos dito. So, u squared times 1 minus u squared, cancel yung sine. So, magiging d na lang yan dyan. So, now we can distribute this sa loob. So, magiging the integral of u squared minus 2 times 2 is raised to the power of 4. Now, split natin siya para magamit yung power rule. So, u is the power of 2 du minus the integral of u raised to the power of 4 du. So, now, gamitin natin yung power rule. So, copy the negative times u raised to the power of 2 plus 1 over 2 plus 1 plus minus pala the integral of u raised to the power of 4 plus 1 over 4 plus 1. So, now, pwede natin isolve. So, magiging 2 raised to the power of 3 over 3 minus u raised to the power of 5 over 5 plus c. So, pwede natin i-substitute yung value ng u, which is And also, distribute natin yung negative na rin na sign. So, maging negative 1 over 3 cosine cube x minus plus kasi negative times negative. So, now maging 1 over 5 cosine 5 raised to the power 5x plus c. So, here is our final answer.
So now we are in our third topic, which is the inverse trigonometric integrals. So inverse trigonometric integrals arise when we have forms like this. These forms often requires substitution to match one of these standard inverse trigo integrals, but not all integrals fit these forms directly. So now we can use these three integrals when the integrand is more complex, like having x squared in the numerator or an unfamiliar algebraic expression. We can also use trigonometric substitution to rewrite the integral in terms of trigo function, then integrate and reverse substitute using inverse trigo. So let's answer this problem number 1. The integral of 1 over 1 plus x squared dx. So as you can see, it matches this integral form. So we can directly substitute this into this result. So but first we have to find the value of a and x. Since we have to find the x squared first, a squared is equals to, the constant 1. Next is the x squared, which is this one. So we can cancel this, and a is equals to 1. So our x is x. So now we can use this result. So 1 over what the value of a is 1. Copy the arctan. The value of x is x over the value of a is 1 plus c, or so this is our final answer. So let's proceed to our problem number 2, which is the integral of 1 over the square root of 16 minus x squared. So in this problem, we can see that it matches this integral form. So we can also directly substitute this into this. But first, like what we did in the problem number 1, we have to find the value of a and x. The value is the constant, which is 16. Square root, cancel. So the value of a is 4. Next is the x. The value of x is x. So now we can use the arc sine x over a plus c. So arc sine, the value of x is x. The value of a is 4. So this is our final answer. So now let's proceed to our third problem, which is the integral of 1 over x times the square root of 9x squared minus 1. So in this problem, it matches this integral form. So we can directly substitute this into this. So let's find first the value of a and x. The value of x is 9x squared square root. And the value of x is 3x. The value of a is 1 square root. So now we can substitute this into this because we already found the value of x and a. So 1 over the value of a is 1 arc second times the value of x is 3x over the value of a is 1 plus c. So we can cancel this. Arc second times 3x plus c. So now this is our final answer. So now let's proceed to our fourth problem, which is the integral of 1 over x squared times the square root of x squared minus 16 dx. So now we can use this integral form because it's more complex, because as you can see it didn't matches to any of these integral forms. So we're going to use, as you can see it matches this integral form, so we're going to use this. So now we're going to find the value of x. Value of x is a, so the square root of 16 is 4 second theta. So we need to derive it. 4, this, the derivative of second is second theta tan theta. So now we need to substitute this to our original problem. So the integral of dx, we need to substitute the dx into 4 second theta tan theta d theta. So going to be 4 second theta tan theta d theta over the value of x is 4 second theta squared times the square root of 4 second theta squared minus 16. So now we need to solve this first and this. Copy the numerator. Over 4 square root of 4, I mean the square root of 4 is 16 second squared. Also here 16 second squared theta minus 16 d theta. So what we should do next is to factor out the 16 here. Copy the numerator. Second squared theta square root of 16. So now it will be only second squared theta minus 1. So next is we need to substitute this into tan squared theta. So copy the numerator. 16 second squared 16. We need to substitute this into tan theta, tan squared theta. So what we should do next is to cancel out the square root. So it's going to be, copy the numerator. 16 second theta. The square root of 16 is 4, and then the square root of tan squared is tan theta. So next is we can cancel this out, this and this. So the remaining is only d theta over 16 second theta. So what we should do next is to put the constant in front of the integral. So it's going to be 1 over 16 du over second. So now we can substitute 1 du over second, I mean d theta over second theta into cos theta. Next is we have to integrate cos theta, which will be sin theta plus c. So now this is not our final answer yet. We need to find the value of theta. So now we're going back here. So we need to divide both sides by 4. It's going to be x over 4 equals second theta. So we need to use this Solayao theta. Since ang kabaligtad ng second is cos, so gagamitin natin ngayon yung Solayao. So, tawa. So yung kabaligtad ng second is cos, so gagamitin natin yung ka. So, cos theta is equals to adjacent over hypotenuse. So ito, magbabalik din to. So magiging 4 over x. So now, ating adjacent is magiging 4 and our hypotenuse is magiging x. Since kailangan natin hanapin yung sin theta, so gagamitin natin ngayon yung pero since kailangan natin yung opposite, hanapin mo natin yung opposite gamit ang c squared is equals to a squared plus b squared. We're going to transpose b squared is equal to c squared minus a squared square root square is no. So let me cancel. So our c is the hypotenuse, which is the x squared, minus our a is the adjacent, which is 4. So this is now our opposite. So now we can find the value of sin theta. So the value of sin theta is ito na lang, opposite over hypotenuse. So the opposite is x squared minus 4 squared over x. So you can now substitute this here. So our final answer is 1 over 16 squared of x squared minus 4 squared over x plus c. So this is now our final answer. So we are now in our last problem, which is the problem number 5. So in this problem, we can see that this denominator is matches this integral form. So now we can use this integral form. So we need to find the value of x first. The value of a is the square root of 4, which is 2. Copy the sin theta and derive it. It's going to be 2 cosine theta d theta. So now we need to substitute this into the ating original problem. The value of dx is 2 cosine theta d theta over 4 minus the value of x is 2 sin theta square root cube. Next is we need to solve this first. Copy the numerator, cosine theta d theta over square root of 4 is square root of 2 is going to be 4 sine squared theta. So now we need to factor out the 4 inside here. Cosine theta over factor out the 4. So it's going to be 1 minus sine squared theta cube. So next is we need to substitute this into cosine squared. It's going to be cosine of the numerator over substitute this into cosine squared theta the cube. So next is we need to cancel out this square root. It's going to be copy the numerator, going to be 2 cosine theta cube. So we do solve this, copy the numerator. So the cube root of the cube root 2 is 8 cosine cube theta. So you can cancel this and we can lowest term this. So 1 over 4 cosine squared theta. Next is we can put the constant in front of the integral, going to be cosine squared theta. And we can substitute this into second squared. And now we can integrate this. It's going to be tan theta tan squared plus c. So now we need to find squared. So now we need to find the value of tan theta. So babalik tayo dito. So we need to find the value. We need to divide both sides by 2, going to be x over 2 equal to sine theta. Next is so using the Solayao, so since its sides is opposite over hypotenuse, so the opposite is x and the hypotenuse is 2. So next is we to find the value of the adjacent. So to find that, we need to use this. No, wait. We need to transpose the b. To find the value of the adjacent, it's going to be b squared is equal to c squared minus a squared. Where is cancel this. So the b is the hypotenuse is 2 squared minus the opposite is x squared. So this is now our adjacent. 2 squared 2 squared minus x squared. So since it's tan, so we need to use the TOA. So tan theta is equal to opposite over adjacent. So the opposite is the square of 2 the square. So we can make this formula minus x squared over the opposite pala is the x. Sorry, the opposite is the x, and the adjacent is this. So now we can substitute this here to find our final answer. Value of tan is x over the square of 4 minus x squared plus c. So this is now our final answer. So now we are in our last topic, which is the integration by parts. Integration by parts is based on the product rule for derivatives and is useful for integrating the product of two functions. The formula is the integral of u dv is equals to uv minus the integral of v du. We typically let u be the parts that is simpler to differentiate and dv be the parts that we can easily to integrate. For example, number 1, the integral of x ex dx. So, but in this problem, I will teaching you a method that we can easily find the answer, the di method. But first, we need to find which in these functions that we need to derive, I mean that we can easily derive and we can easily integrate. Since x is we can easily derive, so we'll be using x as our u or the d x. Derivative of x is 1. The derivative of 1 is 0. And now we're integrating the ex. The, integr the integral of ex is simply ex. And the integral of ex is simply ex. So to find the final answer, we need to follow this. So our final answer is x times ex is xex. Then negative 1 times ex is negative ex plus c. Or we can factor out the ex. It's going to be ex x minus 1 plus c. So here's our final answer. So now let's proceed to our problem number 2, which is the integral of of x ln x dx. So in this problem, we're going to use the formula. So we're going to let wait, since ln x is more easy to derive than to integrate, so we're going to let ln x equal to u. So we're going to let u equal to ln x, that then derive going to 1 over x dx. Then we're going to let x be equal to dv. So dv is equal to x. So integrate. So v is equals to x squared over 2. So now we're going to substitute this to our formula. So the integral of u dv is equals to u. The u is ln x times b. The value of b is x squared over 2 minus the integral of b, which is x squared over 2 times du, which is 1 over x dx. Next is we're going to solve this term. So just copy the first term, ln x, x squared over 2, or we can rearrange this into x squared over 2 ln x minus, we can cancel this, it's going to be x over 2 dx. Then we can put the constant in front of the integrals. It's going to be x squared over 2 ln x minus 1 over 2 x dx. Then then integrate this x dx equal to x squared over 2 plus c. So we need to substitute this here. So it's going to be x squared over 2 ln x minus 1 half times 2 is going to be 1 over 4 x squared plus c. So here's our final answer. So now let's proceed to our problem number 3. The integral of x squared ex dx. So in this problem, I will be solving this using the dm method like what I did in the problem number 1. So d and I. So we're going to find which in these two terms is simpler to differentiate. So we're going to derive the x squared. So it's going to be 2x, then derive again. Going to be 2, then derive again, then 0. Then now we're going to integrate the ex. Then integrate, then integrate. So now we're going to, like what we did before in problem number 1. So our final answer is, we're going to multiply this first. X squared times ex is going to be x squared ex. Then negative 2x times ex is going to be negative 2x ex. Then next is 2 times ex is positive 2ex plus c. Or we can cancel out the e. So it's going to be, dito na, ex times x squared minus 2x plus 2 plus c. So here is our final answer. So now let's proceed to our problem number 4. The integral of x cubed ln x dx. So in this problem, we're going to use the formula. So we're going to find which in these two terms is simpler to differentiate. So we're going to let u equal to ln x, then derive 1 over x dx. Now we're going to let x cubed equal to dv in, integrate is going to be is equals to x4 over 4. So now let's substitute this to our formula. The integral of u dv is equals to u, which is ln x times b, which is x4 raised to, x4 over 4 minus the integral of b, which is x4 over 4 times du, which is 1 over x dx. So now let's solve this term. Copy this, copy the first term, or we can rearrange this x4 over 4 ln x minus, cancel this, cancel, so it's going to be, and we can put the constant outside, it's going to be 1/4 the integral of x cube dx. So now we need to integrate this, going to be x4 over 4 plus c. So now we can substitute this to here. So the final answer is x4 over 4 ln x. We're going to times the constant. So 1/4, -1/4 times negative -1/4 times 1/4 is -1/16 x4 plus c. So here's our final answer. So now let's proceed to our last problem, the integral of x squared cosine x dx. So now we're using the our formula. So we need to find first which term is simpler to differentiate. So we're going to let u equal to x squared, then du is 2x dx. Then we're going to let dv equal to cosine x, then b is sine x dx. No, dito pala yung dx. So now let's substitute this to our formula. The integral of u dv is equal to u, which is sine x, then v is, oh no, u is x squared, then v is sine x, minus the integral of v sine x times du, which is 2x dx. So now we're going to integrate this term. So we need to copy this sine x minus, to integrate this going to be, oh my god, negative cos 2x over 2. So we can substitute this here. It's going to be, since negative times negative, so it will be positive cosine 2x over 2 plus c. So here's our final answer. Thank you so much for watching. I hope this video helped you better understand these key topics in integral calculus. If you found it helpful, please give it a thumbs up and share it with your classmates or friends. Good luck with your studies. Keep integrating and keep learning.